In this presentation, we're going to discuss about strings in C or character arrays. Normally, a group of alphabets enclosed within double quotes is a string literal in C. Basically, strings are just array of characters in memory, normally end with a byte with value 0 or null. This kind of strings are also called null terminating strings. So as they are character arrays, all the rules applicable to array is applicable to strings as well. So now we're going to see a demo to print characters in a string to prove that it is an array of characters. So we have an array of characters here which is initialized to hello world. So what I'm going to do here is in this printf statement, I'm going to access each element in the array and print one by one. So that is what is happening here. I have a counter I which I'm incrementing up to 11, which is the length of this string. So this hello world is 11 characters. And in the printf statement, I have a %d to print the value of I. I have a %d here to print the value of the element. Also I have a %c here to interpret that particular value as a character. At last I have a printf statement here to print the entire array. So this is the output of the application. So 0th character is H, which has a value 72. So number 72 is H. 1 is 101, which is E, small letter E. 2, 108, which is small letter L, etc. So I have hello world here. And the array is hello world, which I have printed at the end. So let's go back to our presentation. String.h. String.h is a header file which helps us to manipulate strings in C. It has a lot of functions inside it. For example, string copy to print off into a string array, to compare two strings, concatenate two strings, get the length of the string, etc. are some of the examples. Some of the old functions has some security issues and has been replaced by newer version of those functions, but we don't care so much at this point in time. Now we're going to see a demo of string.h and how we can use it. So this is a program which is using string.h to manipulate strings. So in this program we have 3 character arrays of 25 elements each. So I have initialized all these 3 array to 0, so which means that the elements contains nothing but 0. Now I am just printing it. So in this printf statement we are expecting nothing because it is all null. Now I am copying hello to first one and world to second one using the function called strcpy, which is from string.h. So strcpy is a function which we can use for copying strings. That's what I'm doing here. So this is the destination and this is the source. So after this statement, this will contain hello. After this statement, this array will contain world. So to prove that, we are printing it again. So again, our third string is empty. We have not done anything with the third string, so it will be empty as well. So now what I'm doing is I'm concatenating 2 strings. So first what I'm doing is I'm concatenating string 3 and string 1. So string 1 contains hello at the moment. So string 3 is empty at the moment. So string 3 will become hello. Now again I'm concatenating string 3 and string 2. So string 3 is already hello and string 2 is world. After the execution of this statement, string 3 will contain hello world. So the function I'm using to concatenate string is strcat. It is also from string.h. After that, I'm printing all the 3 strings here. In the end, I am using string compare to compare these 2 strings. We will see the details of string compare in the documentation in the web. I have executed the application and I got this output. So initially, this printf statement is giving no output. It's just empty strings. So after that, I have copied hello and world here, and I'm getting this printf here. Again, my third string is empty. In that case, I'm not getting anything. After that, I'm concatenating. So I got hello world, and in the end I got a -1, which is the result of string compare. So what are the different functions contained in string.h? So if you go to web and search for string.h, we'll probably end up in the documentation of the string.h. So for example, this is the documentation of string compare. So these are the input it takes, and this is the return value of it. String compare returns an integer value indicating the relationship between the strings. A zero value indicates that both strings are equal. So if both strings are same, it will return 0 value. A greater value than 0 indicates that the first character that does not match has a greater value in string 1 than string 2. And a negative value indicates the opposite. So in our case, we are comparing hello and world. So the first character which is not matching is H and W. So H is less than W. So we got -1. Array of strings. So string is already an array of characters. So array of string is array of characters. So which means that it is a two-dimensional or multi-dimensional array of characters. So we have seen arrays, but we have not seen multi-dimensional arrays. So we're gonna see that. So we're gonna see a string sorting program using multi-dimensional arrays. So in this program, I have a multi-dimensional array of characters. So it has 2 dimensions at the moment. So this is basically an array of characters which has 25 elements. So we have 5 such arrays. So we have 5 arrays of array of characters which has 25 elements. That is what this statement means. I'm initializing the entire array to 0. So that's what being done here. So there is a nested curly braces with 0 inside. So which means that I'm initializing this entire array to 0. So the value of each and every element in the two-dimensional array is 0. Now what I'm doing is I'm initializing it with valid data. So I have an unsorted list of strings which I am copying to each element. So 1, 2, 3, 4, 5. So we have 5 here. So the first character array I'm copying this. Second character array I'm copying this. I'm using the function string copy or strcpy. So after this copying operation, I will have these values inside this array. So let's see that. So I'm putting a breakpoint here and executing the code. So if I look at this, so I have in the debugger I can see all the values which I have entered in the same order. So now what we're gonna do is we're gonna sort this. So this order is not in any sorted order. So now what we're gonna do is we're gonna sort it like in the dictionary. So this will come first, this will come second, third, fourth, and fifth. So the same algorithm we are using, which we have used in the case of decimals to sort. So we have two for loop. It's not the most efficient way to do this, but for the purpose of simplicity we are using this algorithm. So we have two for loops. One is nested inside the other, and we are comparing the strings here. So this statement is a little bit lengthy. Let me explain what it does. This equal to is not equal to equal to. I have purposefully done it is equal to, so don't get confused. So what I'm doing is I'm calling string compare function to understand which string is higher in the sort order. String compare, as we mentioned earlier, will return either 0 or a negative or positive value. If it is a positive value, I am interchanging the strings. So this is very similar to the sorting application or the sorting algorithm we have seen in the decimal. Only difference is I am using string compare instead of the normal. So being said that, let's debug into the program. I'm going to press F10. So my I became 0. Everything else is junk because they are not initialized. Now my J became 0. This is larger than this, so we're gonna swap it. So the swapping algorithm is exactly same as before, like in the integer case we have seen. So if you continue that, so I'm going to press F5 to see the result. So I got all the elements sorted, A, B, C, D, Z, which is at the end. So now let's go back to our slides again. So we have seen sorting of the array, and we have seen how to use a two-dimensional array as well. So I would like to give you a couple of words about something called Unicode here. So all the strings we have seen so far is character array or 8-bit number array, or array of numbers which is of size 8-bit. 8-bit can hold up to 2 raised to 8 or 256 different numbers. So in certain languages like Japanese, some of the Chinese scripts has more number of characters than 256, which means that those languages cannot be easily represented using 8-bit numbers or 8-bit characters. For that, industry has come up with a different solution called Unicode, which are characters of 16-bit numbers. So Unicode is the modern way of representing strings, and the character array is a little bit older way of doing things. So I'm not going into the details of Unicode at the moment, but let's try to understand the fact that all the major operating system programming languages support and recommend Unicode instead of 8-bit character arrays. And that's all. Thank you very much.